In this demo, we're going to implement paging functionality. As an example, we'll do this on our cities collection. Within the Get Cities action on the cities controller. Here we want to accept two additional parameters via the query string, page number and page size. It's important to give these parameters default values. Like that, we can ensure that if a consumer doesn't pass through values for these parameters, these defaults will be used. Let's say we'll default page number to 1 and page size to 10. There's one more thing we have to think about, a maximum page size. We've got a default here, 10, but a consumer of an API can still input 1000 and that will be accepted. That should not be the case, as that would have a negative impact on performance. So we'll add a constant that defines the maximum page size. Say 20. I tend to have a maximum page size value for each resource collection instead of one general maximum page size for all resource collections. This is because you might want to let consumers of the API get a maximum of 20 cities per page, but maybe 30 points of interest per page when implementing paging on that collection. Now we have a maximum page size, we should take that into account when setting the page size. We need to check if the page size isn't larger than the maximum page size, and if it is, we set the page size to the maximum page size. And with that, we've got our parameters. Let's pass these through to our getCitiesAsync method. And now we have to change the contract and implementation of our repository, so these are accepted. So we add these in the getCitiesAsync method on our iCityInfo repository interface. And we do the same on the repository implementation. Our repository method implementation currently implements filtering and searching. We want to add paging functionality to this. As mentioned right before the demo, we need to make sure that our pagination is done at database level and not after the records have been fetched. That can be done thanks to deferred execution. We already saw that principle at work. Collection we start from is an iQueryable of city. Potentially a filter and search query are applied. In other words, we are building a query. And the query is only sent to the database at the end when the toListAsync statement is reached. So what we can do is apply paging to this collection right before calling toListAsync. It's important to add paging functionality last, because we want to page on the filtered, searched, and ordered collection. If we add paging first, the where and other extension methods will execute on the small paged set of data instead of on all the data, and that would lead to incorrect results. So what we want to do is first skip an amount of orders, the page size times the requested page number minus 1. That'll ensure that if, for example, page 2 is requested, the amount of items on page 1 will be skipped. And then we take the current requested page size. One more thing, if we scroll up, we can see a statement that ensures that all cities are returned if the name and search query are empty. That's great if you only have those two pieces of functionality implemented. But in our case, we want to get rid of that. We learned that we want to apply paging no matter what. And that includes when no filter or search query have been inputted. So let's get rid of that statement. And that's it. Let's save all of this and let's give this a try. First, let's send a request to get all cities. We don't pass through any paging parameters. So this should return us a paged set with the default restrictions, the first page of 10 cities. Small issue is that we only have 3 cities in our database, so we don't see a difference. Luckily, there's another way to check whether our parameters have been passed through correctly. By looking at the generated query. What we see is that the query first orders the city set and then offsets it by a parameter. That is filled with the value of skip. Then it fetches another amount. That's a parameter filled with what we pass in take. So all of this is sent right to the database. We're not first loading all cities in memory, Instead, only the amount requested is fetched. Alright, let's try inputting paging parameters. Say that we're going to start with getting the first page with page size 1. And there we go, we get back Antwerp. That makes sense because the cities are ordered by name and Antwerp starts with an A. So this is the first page number and it only contains one item because the page size was set to 1. Let's try getting page number 2. And there we go, that's the second item in our ordered collection. So far so good, paging seems to work, but something seems to be missing. If we're paging through data, especially with defaults in place, we should return some metadata related to the resource collection. Like that, the consumer can get essential information on the resource, like the current page or total amount of pages, together with the response.